or not. When I question, this is like the back page of your review assignment that you were given. This is basically with every of my classes, you guys. What I present up front, all your notes or all you're taking, anything I put on the board is probably important. Some of you have different background, right? So depending on if you have this background or not, whether or not you need this example or not for this review, okay? The other thing we're going to talk about before I actually get started in our Unit 1, like our actual unit today, we're going to talk about solid, liquid, and gas in those states. I've got a page that we got in like grade 10 or physical science about that told you how do you decide something's solid, how do you decide something's liquid, how do you decide something's gas. On this first assignment, I'll just point out that it's wrong, okay? I won't deduct marks, okay? However, as we carry on in the future, you should have this commonality kind of thing figured out. How do I know it's a solid? How do I know it's liquid, gas, or aqueous? Okay? The last thing is we'll probably talk about science fair and just the due date of the initial hand-in page of your concept. Okay? So this first example says glucose is used as a source of energy by human body. The overall reaction is, part A, write a balanced equation. So the first thing I look, carbon 6 on this side, so I need 6 on this other side. Hydrogen 12, I need 12 on this side, so I put 6 here. Okay, right now I have 8 oxygens on the reactant side. Here I have 6 times 2, that's 12, plus 6 times 1, that's 6. 12 plus 6 is 18. How do I make an 18 over here? I need a 6 in front of the O2 because then 6 times 2 is 12, plus 6 is 18, and then we don't change the other C6s and H12s, right? So we have a balanced equation. Next thing we should do is look at the next part of the question. So it says, calculate the grams of H2O produced if 3.5 grams of C6H12O6 were present with excess oxygen. Okay, so they give you so much grams of sugar and ask how many grams of water. Okay, well this is kind of like a 3-step thing because in order to move from one type of molecule to the next, you have to do a mole conversion. So in order for that to happen, you need to have the amount in moles. So the first thing we're going to do is we're going to take the grams of sugar and change it into moles of sugar. Okay? So if I have grams of sugar, I have 3.5 grams of sugar, and I want to know X moles of sugar, which is C6H12O6. How do I do this? We need the molar mass. Now, what do we need the molar mass of? Not water. We need the molar mass of C6H12O6. Okay? So, for our purposes, we are not going to use the periodic table in the back of your textbook because it has different numbers than the periodic table in our booklet. So we're going to use it from our booklet. What is it? The green page, right? So when we look at it, carbon, and I just do it on the side, carbon is 1201, and I times it by 6. Hydrogen is 101, I times it by 12, and oxygen is 16, and I times it by 6, and then I add those total things up. Is that correct? Did I get any numbers wrong? Because sometimes I'm just going off my head, right? So sometimes I get them wrong. So I go, bring this over here. 1201 times 6 plus 101 times 12 plus 16 times 6. So when I do this, I get 180.18. Okay? So that's the molar mass of sugar. 180 point, what did I say, 18? Okay. That's grams, molar mass of sugar. So that goes underneath grams. So whatever you've listed in grams, that's where you put it underneath, 180.18 grams. That's the special number for grams. What's the special number for moles? 1. Remember, we had 1 mole equals the molar mass, which is equal to 6.02 times 10 to the 23 atoms or molecules. Those were our special numbers. Okay, so I put 1 here, 1 mole. How do we solve? We cross multiply and solve. So we actually get 35 is equal to 180.18x. So, 3.5, you're right. 3.5 is equal to 180.18 times x. To get x alone, I divide, right? So I get 3.5 divided by my 180.18 gets me 0.0194. What do you have to remember with chemistry, you guys? You have to carry all your decimals, okay? So either you write them all down, or you can type them back in, or you can hit the second answer button, right? So x is equal to 0.019 blah, 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 moles of C6H12O6. Okay? That's the first step. The first step is to make sure that we have this working. But what do we want to find out about? We want to find out about water, right? Not sugar. We want water. So then we do a mole to mole conversion. The second step is to do a mole to mole conversion from sugar to water. Okay? Now I'm in a Word document, so I'm going to pull this number up so that I have it. And I'm going to do a little bit of an erasing. Okay? So the second step is to do a mole to mole ratio. So when we do a mole to mole ratio, we compare what we want, or what we have, to what we want. So we have sugar. What's the moles of sugar in this general equation here? So if I look up here, what number is in front of C6H12O6? 1. So I say 1 C6H12O6 is equal to how much of water? 6 H2O. I put the number I have for sugar, 0.019, and I know I have more numbers than that, is equal to x, because we want to know how many moles of water do we have. So then we cross multiply. We end up with x is equal to this 0.019 times 6, right? So if I pull up my calculator, I have this 0.019. I just have to times it by 6. And I get 0.11655 with lots of decimals. 0.11665, and this is moles of H2O. Now, sometimes that's all they want to know is how many moles of water. But in this case, what? It asks for grams, so we have to do that third step. Okay? So that third step, and now I'm going to erase this because I don't need that. But I'm going to pull up this new number that we came up with. Now you guys don't have to because you're going to follow on your paper, but this is just so that I keep it in my head. Okay? So the last step is we take how many moles of water we have, 0.11665 moles, and we want to know how many grams of water that is. What's the special number for moles? 1, because 1 mole equals 6.02 times 10 to the 23 atoms or molecules, which is also equal to the molar mass. So the special number for moles is 1. What's the special number for grams? The molar mass. Okay? So, the molar mass of what? Of H2O, what we're doing here. Okay? So, what is H2O? Well, that's 2 hydrogens, which is 2 times 101, plus 1 oxygen, which is 16. When I multiply and add them, that gives me 1802. Some people will need a calculator for that. If you need a calculator for that, what happens to your decimal? Like this 1.11665, it goes to the line above. So you either have to retype that into your calculator, or some of you have the fancy calculators where you can arrow up and highlight that number. Okay? Some of you don't have that. Okay? So I put 1802 here, and I cross multiply. I get x is equal to 0.11655 times 18.02. Gives me 2.1002. Now, how many sig figs can I have? 2. So my answer is 2.1 grams of H2O. You should always put what substance you calculated in your answer. Okay? So this is an example like that last page. It's using mole conversions to solve answers that you want to know about in your laboratory. Okay? Now, the second thing I wanted to talk to you about is this page about states. My grade 11s will recognize it. My grade 12 should recognize it, but it might take you a while to think about it or figure it out because it's been about a year and a half for you for looking at chemistry kind of stuff. Okay? So if you read through this will help you, but I would say as grade 11s, we took notes on this, right? We went through it and we made it simplified for us, right? We highlighted the important parts. So take some time if you're stuck at how to make solid, liquids, and gases. You have some reading, okay? And I'll give you this handout sometime today. It's printed off in the office. It's just we need to get there, okay?